So today we have to discuss how files are stored on computers, how files are visualized by the user and by the system, by the operating system and by the storage structure. The hard disk, the magnetic hard disk drives that we are used to using even in these days, they were replaced by magnetic tape drives, and now these disk drives of this structure are being replaced by solid state drives, which are SSDs, or solid state drives are just large capacity USB flash drives kind of thing, and the technology inside is very similar to flash drives that we already use on the USB port. So but I'm still going to quickly go through what the mechanical disk drive was and is still in certain places. So this was the structure of the mechanical disk. So we cannot see these divisions physically on the surface of these platters, but we logically make them. These are called tracks, and this is a head which reads the surface of this magnetic disk from the upper side and from the lower side, and you can have multiple platters in one disk as well across this spindle, and the you can say the divisions inside this track are called sectors, and multiple sectors of multiple platters, they they make a cylinder, and this arm assembly, you can say that it moves in this direction like this. It goes from here to here or here to here, so it covers this direction of the surface. While this spindle moves, it rotates in this direction. So during rotation and with the movement of this head, collectively we are able to cover all the surface area of this platter, and we are able to change the domain, the magnetic orientation of domains on the surface, and the surface is such a surface that it is very easy to have the data stored on its surface for a very long period of time without the use of electricity. So that's why these are you can say can be used for permanent storage, or they can be changed easily as well. So the domains on this surface are changed very easily using applying magnetic force using these read-write heads. So long story short, I would say we used to have these hard disks. They came in different sizes, different spindle speeds. So there was a lot of variety available to us in terms of sizes and spindle speeds. And there's obviously there was excess latency, which was the seek time, and the average latency, which varied a lot from faster disks to slower disks, and the capacity of the disks was also quite variable. And solid state disks, on the other hand, they are more reliable than the hard disk drives, as we called the magnetic disk drives, and they are more expensive per megabyte. They have shorter lifespan, but these obviously these two things are changing quite rapidly, and similarly they have less capacity. Again, this is also changing, but this is not changing, which is that it is actually improving, that they are much faster as compared to the hard disk drives. So but the bottleneck are the buses which connect the solid state drives with the main computer. So you directly connect them to PCI ports, for example. These are parallel data ports, so the data rate is much higher. But there are due to not having any moving parts, any mechanical parts in solid state drive, these are much faster as compared to hard disk drives. So these have taken a lot of space in user domain as well. So now in my computer, in the computers of many I know, are totally switched to solid state drives in and they don't use the hard disk drive. So but if you're talking about the disk drive, what we need to understand is that irrespective of the physical structure of the disk, we visualize the disk as a simple, you can say, a linear array of blocks. So these are blocks, and just like these dots, you can say each dot has a number, so the number of these blocks it goes on sequentially. So even in SSD or the hard disk drive, these numbers go sequentially from logical block number 0 to logical block n or any last number. Each logical block will have multiple bytes that you can store on that logical block. So the operating system now, it is just going to address the hard disk using these logical block numbers, right? And the issue that how the logical blocks are mapped to the physical orientation of the disk. Like for example, it's a mechanical disk, so the logical block it can represent multiple sectors on one of the platters, but at the same time the solid state disk, it can simply it is a two-dimensional array of addresses, so it will simply go to a certain point in its two-dimensional array, and that will be your logical block. So this mapping of logical block number to the physical existence of that data, we say that we leave that to the what we call the controller of the storage device. So there is a tiny computer that resides on top of the storage device. It's a tiny computer. It's normally green color circuit board, which is on the bottom of the storage device. So that controller or that computer is responsible for translating the logical block number to the physical location of that data. So right now we're not really much concerned about that translation. Why do I say that? I say that because if you go through the rest of this topic, you will see that we did something that was called disk scheduling, which was quite frequently done previously, because we used to use the hard drives more as compared to SSDs. But in my opinion, for coming time, we won't be using this too much, so this may become irrelevant. But obviously the backward support will be there, and it will be backward compatible, but in my opinion this is going to vanish, this is going to disappear. But just to give you an idea, the surface of the disk contains different logical blocks or sectors. One logical block can be one sector, or it can be multiple sectors. Each sector can have multiple bytes, so definitely logical block will have multiple bytes. So it will take, for example, right now your head was pointing at this, it was resting at this point, and the last data that you read was from this location, and suddenly you had to read this location. So now your head will have to rotate in such a way that it will have to realign itself towards this thing, right? So it will, because it's a mechanical thing, it will have to take some time. This rotation will take some time. And similarly, if you go from this point to this point, obviously this rotation of the head is going to again take a lot of time. So these tiny amounts of time, which are not of course too much, but when they add up together, it really shows a decrease in performance or the quality of user experience. So you don't want to have too much delay from the movement of the head, and you want to reduce the movement of the head to and obtain the same amount of data, right? So by the way, just to tell you that the head never physically touches the surface of the drive. So it never touches, it is apart, slightly away from the surface, and there is air gap inside. So the picking up of data is quite fast. So you don't need to physically touch this thing. Actually, if you touch it, the surface will go bad. The normal distance between the head and the platter is 10 times smaller than a dust particle. So that makes the reading of the data even faster, because it's very near, but it still doesn't touch the surface of the platter. So we had different algorithms like first come first served, shortest seek time first, and the scan algorithm or C scan algorithm. These algorithms, the objective of these algorithms was to reduce the time it takes for a string of logical addresses that are sent to the hard drive, and it wants to reduce the time it takes to read all of these logical blocks. But in the case of SSD, the time it takes for any block and going from one block to another is the same. So you don't need to worry about these algorithms anymore in terms of SSD. But there is another algorithm which deals with increasing the lifespan of the SSD, and it scatters the data in such a way that you do not keep on rewriting to the same physical address inside the solid state drive. So if you keep on doing that, there is a limited number of times you can rewrite to a byte inside a physical byte inside the solid state drive. So if you keep on doing that, for example, after 1000 rewrites or 2000 rewrites, that byte is going to go bad and it will not be readable anymore or writable anymore. So you want to reduce that. So now we're going to do the opposite. So in when it was hard disk drives, we wanted to have the data near to each other for one file. But now what we are doing, we are going to scatter the data across the surface of the SSD so that the lifespan of SSD can be increased. So having said all of this, in my personal opinion, this chapter becomes slightly irrelevant, except this part that storage area network is very common. So now here you can have multiple hard disks. These storage units can have one or multiple different types of storage devices, and all of those devices are connected to a network, and that network is connected to another network using some computers. And similarly, there can be managerial units which are using or managing the data on all of these storage networks, and collectively they give an illusion of a very large storage device which can have millions of terabytes as a single unit. So these are called network attached storage, and it's a protocol that uses storage media. It makes the storage media available over a network rather than over a local connection and remotely attaching to file systems. There's another file system for that, NFC and CIFS. These are common protocols implemented via remote procedure calls between host and storage over typical TCP or UDP or IP networks. iSCSI protocol uses IP network to carry this SCSI protocol and remotely attaching to devices. So these things are obviously much more modern things. The cloud computing, the cloud storage, all of those things are using these technologies. So let me actually draw something for you. For example, here I can do that. So for example, this is the operating system, right? And we say that this is the storage device, right? This is the storage device. It could be the SSD or it could be the hard disk drive. It can be anything like that. So the internal details are hidden from the operating system because there is a computer on top of this. This computer is capable of receiving the address of logical bytes in terms of numbers, simply number 2, for example. So the operating system is requesting to read or write to logical block number 2, where that logical block number 2 is stored inside the storage media is totally up to this computer. So this computer is going to translate this logical address into the physical address onto the physical surface of this mass storage, and we will not be concerned with that too much for now, and we will simply think in terms of logical addresses. So now any questions from this part? So all you need to know right now about these algorithms is that they want to reduce the latency or the seek time of the head to look for data inside the structure. For booting from a disk, you need on which you have defined partitions. You're able to define partitions. You're able to name the partitions as you like. And then there is on top of all of this data, on the starting sectors or starting logical addresses of the disk, there is something called the master boot record. And that master boot record consists of the boot code and the partition table. And it takes you to the it allows you to select the operating system that may be installed on this or installed on this. So here you may be having Windows, here you can have Ubuntu, here's some other operating system. So there can be a mini menu stored at this part which lets you select the boot partition, and it takes you to the boot partition to start the operating system which is installed on that particular partition. So every partition can only have one resident operating system, and if you want to have multiple operating systems residing on the same disk, you have to partition them into different partitions to make the management easier for the operating system, because one operating system, when it is running, it won't be able to handle another operating system on the same partition. So if you want to run multiple operating systems in the same partition, you must use the virtual machine approach, which we slightly discussed earlier.